here with Aubrey Gower from Zehnder, and we're going to be talking about their latest and greatest heat recovery ventilator.
Let me start out with the basics. When you build a house very airtight, which is a very important component of building a very energy efficient house, is air sealing the building so you don't get cold outside air infiltrating or warm outside air in the summertime infiltrating. At that point you need to actively ventilate the house because there's still people inside that need to breathe, and they're going to be breathing out carbon dioxide and making odors, so all that needs to be exchanged. The typical way of doing that in the past has been just a kitchen range hood and bathroom bath fans. Those don't work so well anymore once your building is very air sealed, because for all the air they move out, air needs to come back into the house. And if you've closed off all those paths for air to move back into the house, then they just work like crazy but don't really move much air. So at that point you need a balanced ventilation system, which is both exhausting air out of the house, out of your moisture points like the kitchens and bathrooms, and then bringing an equal amount of fresh air back into the house so that your building stays pressure neutral and the air is actually exchanged. Once you're doing that, it makes a whole lot of sense to have a heat recovery ventilator, which is the product line that we have, which is a heat exchanger by which the exhausting air preheats the air that's coming back in. And there's a range of these available. Ours are the most efficient, with heat recovery rates in the mid-80s to mid-90%. So that's the core of the technology.
Can you show me on the unit where the incoming air is, where the outgoing air would be?
Absolutely. This is the air coming into the house, goes through here, and then is supplied out through here. And this air would then be distributed throughout the house into the bedrooms, primarily other closed off in rooms of the house. And then sometimes in the open great rooms, living rooms, what have you. And then the returning air coming out of the bathrooms and kitchens come back in through this port, go through other ports in the heat exchanger, and then get exhausted back to the outside. So within here, this is the heat exchanger, and then there's a couple of fans that move the air to the outside, air to the inside, and draw it through the system.
And what kind of material is the heat exchanger made of?
These heat exchangers are made of a polypropylene. The material is right here. The reason that we're able to get such high efficiencies is this is what they call a counterflow heat exchanger, where in here, all of the, basically, if there was a bunch of these and you sliced it down the middle, it would look like a bunch of corrugated cardboard, in a sense, a whole bunch of tiny little cells, where half of the air is flowing in one direction, the other half of the air is flowing in the other direction, and they pass by each other in a parallel fashion that allows a large surface area for the most heat transfer possible.
Thank you, Aubrey.
You're very welcome. Thank you for your interest.